Hello, I am Marco Rabe and I'm the product manager for bearingless encoders and therefore for the new EB200E IO-Link encoder as well. Today I would like to give you an overview of this new smart encoder and the possibilities combined with the Baumer sensor suite. The EB200E is the new smart bearingless encoder. It is an encoder that has all the advantages of bearingless encoders. This is the sensor here and the magnetic rotor, which is mounted on the shaft. The two parts are separated from each other, so it is totally wear-free. Additionally, it's extremely compact in the integration compared to the classical shaft encoders, as you can see in this comparison. In addition to the general advantages, the EB200E is an extremely flexible encoder that offers 3 use cases in one product, thanks to the IO-Link interface. The first use case, we have the IO-Link encoder use case, where the EB200E is connected to an IO-Link master, and from there to the PLC. The second use case is the Programmable incremental encoder, where it is connected to the motor controller via the HDL signal output, and from there to the PLC. Number 3 is the speed monitor, where it is connected directly to the digital I/O of the PLC, standalone without any further signal evaluation needed. After this short overview, I would like to show you what the EB200E is able to do. We connect him via Baumer USB-C IO-Link master with our laptop. When the EB200E is found by the BSS, we can go directly on the add-on for the EB200E. This is a great tool to visualize and parameterize the encoder. First, let's talk about the process data the EB200E has. We have the 2 measurement values, speed and position. Here you can see them in the 2 graphs. On the top, the speed graph, and on the bottom, the position graph. Additionally, on the right-hand side, you see them always in the add-on. The process data contains also the 3 SSCs, speed, direction, standstill, and the alarm bit. Underneath the states, you can see the condition data. This is some additional data, for example, temperature, operation time, and revolutions counter. If I would show you all the parameters of the EB200E, we would be busy for quite a while, so I have only picked out a few. For example, the unit setting. You can switch between RPM and speeds per second. Take into account, if you choose RPM, that you have to select the right scale setting as well, to have the correct RPM output. If you switch to RPM, you can see that graphs adapts to RPM as well. The interpolation settings are right underneath. This is the parameter to adjust the impulses and steps the HDL encoder transfers over 1 revolution. The factory setting is 8-fold, as you can see here. So let's change it to the maximum interpolation of 16-fold. Now you can see how the steps per revolution went up to 4096. We have a magnetic rotor with 64 poles times the interpolation factor of 16, and the 4-edge evaluation makes 4096 steps per revolution. So that is how you can parameterize this encoder and then use it as a normal HDL encoder with the steps per revolution you need in your application. If you want to use one of the switching signal channels, you have to click on parameterization and then on switching signal channels. Now you are at the speed monitor interface, the SSC1. On the left side are all the parameters for the speed monitor. In the middle is a speed over time graph, and underneath the state of the speed monitor, currently on high. To change the speed max, you can easily move the slider to the preferred position, or type in the amount on the left side into the speed max parameter. That's the overspeed monitor. When you are over the speed max, the SSC1 changes to a high state, underneath back to low. This can be used to detect the overspeed of a conveyor belt, for example. If you select the window mode, you change to the speed range monitor. Now we have to set speed limits max and min. If we are in between those 2 limits, we have a low state. And when we are leaving the area, it changes to a high state. To map the speed monitor to one of the physical outputs, we go to Input-Output. factory setting is the HDL output. That means signal channel A on output A and signal channel B on output B. To change that, we just click on the preferred SSC, in our case the speed monitor, and we already assigned it to the selected output. You can change between direct and inverted mode as well, and see the real output in the graph. You can also combine different SSCs, for example the speed monitor on output A and the standstill monitor on output B. Now you have parameterized the EB200E as a speed monitor with the Baumer sensor suite. I hope I could give you some insights on how easy and fast we can do that. Get in touch with our Baumer sales representatives all around the world to get a live demonstration of the new EB200E. Thank you very much.